the
See,
conditions, particularly the medical conditions.
right. See, AI as a model would only have access to the data that you give it. So, in case if you have any confidential information, so to expose it to AI, before exposing it to AI, your personal identifier PII data, before giving it to the AI, you should have certain processes or internal to your IT team that this data should be masked all the time. You have to ensure that your data is secured within your organization before giving it to the before sending using that data to the model. In fact, even in banking industry also, in case if models are being built, models are not given with any confidential information. Models are given with masked data or encrypted data. It ensure that the data engineer or data scientist would ensure data engineer would ensure that data is already masked and PII data is not available, and data scientist will not accept any data if it is not masked or which is not encrypted. So thus checks are being done in real time industry.
I do agree with that, but there is a background story to it on the health HL7 platforms and mirth, which is also involved into it. Don't we feel that we have to again mask the complete platform before it gets exposed properly? And what are the threats?
Having said anything, ethics are something that is, is our top priority of an AI model. In case if we find that anything there is a threat to the basic necessities of an human, then definitely it has to be uphold for a while until we think of a solution for it.
Thank you.
Yeah, I think we'll move on to the next. Thank you.
Thank you so much, sir, for your valuable info presentation on AI. Moving ahead, I now welcome Mr. Saurabh Rai, Vice President of Engineering and Machine Learning, Data Foundry, for his keynote on unified data analytics. So, Mr. Saurabh Roy is currently the Vice President Engineering and Machine Learning in Data Foundry. He has over 23 years of experience in life sciences and healthcare. Saurabh Roy has worked for the past decade as an enterprise architect and is well versed in AWS, Azure, and GCP. He was previously with Paraxel, HP, and Philips before joining Data Foundry. So, please.
Good morning, everyone here. So I'll try my best to keep you awake as much as possible. Today, I'll probably talk about unified data analytics and platform. Can you turn on? So unified data analytics, why data? What is the focus here in unified data analytics? It's a data. Focus on data. Traditionally, they always wanted your money. Now they want your data. From anybody who's calling up to sell you anything, if they get nothing, they still want your data. So data is gold, right? So I think we have plenty of jargons in the industry. I will also try to bring perspective to some of the jargons. But unified data analytics, I think it's a fairly self-explainable term. So you have data and then you're trying to unify it and get analytics on top of it. So let's see what is the need for unification. Okay, so I think a lot of people might have seen this. Traditionally, we started with 4 Vs, 5 Vs, and now we have 6 Vs and 7 Vs finally. So I'm not going to go through each of them, but this is fairly common. You can Google. I'll go through some of them, which probably will resonate with most of you here. So these are the challenges with the data that we deal with. The first is variety. So data happens in silos. It happens in your line of business applications. It is happening on social media and probably everywhere that you touch. And then they're happening in different shapes and forms. They're happening in databases of your applications. They are happening in as tweets on Twitter. They're happening as posts on Facebook. The whole documents, if you consider office documents, PDFs, you talk about audio, video, they're all data. So there essentially the need for the unification comes in because the forms are so disparate, it's not, you're not able to process it in one go in a very simple manner. So then there's this velocity. So we all, this is an information age. We want it available on the right time when you actually need it, and you want this huge amount of data to be processed as quickly as possible. And then there is this volume. So we already know there is an information explosion. Every organization and their ecosystem of suppliers, contractors, and so on, there is an explosion of data, and that data has to be managed. Then there is veracity, variability, and then obviously you want to visualize it. You need to understand what your data is. You want to make sure that your data is correct and complete. And finally, the heart of it, why you're doing all this is to derive value. What is value for data? Something that conveys something to you based on which you can eventually take an informed decision. So that's the value you want to derive out of all this, the 7 characteristics or the challenges that you have of data that you overcome, is to get the value out of it. So unified data analytics platform, you see I spoke about variety, so the formats I just put out here for convenience. What comprises the data analytics platform is the various forms of data in this form of image, audio, video, text, tables, column, markups, and so on. And then you have velocity. You absorb the data, you ingest the data from variety of sources, be it social media, your office documents, literature databases, journals, and so on, and applications, of course. And then you process them. And then that leads you, when you ingest, it leads you to a huge challenge of how you manage this, organize this data so that you can retrieve them in the form at the time that you really need it. So veracity, variability I did speak about, is about completeness and accuracy and consistency of data. And finally is the visualization. You understand your data, what it is trying to convey, and then drive those actionable insights on which you can take decisions. So if you see the variety of data formats, you have structured data. So what is structured data? Typically, if you think, we always think of tables, databases. Any application that you use stores data most often in relational databases. You create tables. We have other forms, columnar databases, and so on nowadays. But that's essentially structured data. Unstructured data comprises of your social media, audio, video, documents. All of those we spoke about. Semi-structured data, it could be events, it could be a website data, it could be data going out of your sensors, your medical devices, which has some form of structure, and some part it could be proprietary also. But then you still, if you get to a understanding of the data, you can eventually extract some value out of it. So these are the 3 broad varieties that you have. Oh, and then we're unifying it. We put it like a data lake. So you bring the data and you try to unify so that you can get some analytics out of it. And this is also how traditionally we had been doing. How do you ingest data from variety of applications, variety of sources? So most of it, if you think of Twitter, Facebook, and others, websites, events, they are mostly in the form of streams. Even IoT devices, mobile devices, you can consider there as streams. And then you capture those streams and store them in the form that you do, and then process it to extract information out of it. ETL, so it is ETL and ELT, some jargons has been around for last 20 years. Extract, transform, and load, and then we do extract, load, or transform. These two technologies or patterns are also been there for quite some time. Change data capture, so CDC, that's essentially extracting whatever you did today and you stored in your databases. Can you extract the data on a differential day-to-day basis? And this has to happen across multiple databases. And then you clean them, transform them, and process them. So that is what velocity is about. So this is a slide on how you organize data, and I'll talk about the history. So traditionally, we always like a centralized, well-governed store or well-governed approach where everything is at one place and we govern it. Traditionally, we have been using data warehouses. The challenge with data warehouses were that we had accumulated so much data that we could not process it. It was an overwhelming task to get anything done quickly in time. So what happened? We then came up with several other notions. We came out with a pattern called data lake. So what does data lakes do? Say you bring your data in whatever form and structure. Warehouses typically would be relational or columnar format. That's an extension of a large database, if you want to say. But lakes, they don't tell you the data has to be in this format. They could be structured, they could be unstructured or semi-structured, doesn't matter. You could bring in, it's something like a landing area of your data, wherever you are eventually accumulating from variety of sources. And then you process it from that data lake. Now here you see there is another term called data marts. So they originated out of warehouses where you said we focus on a particular segment or dimension of data